In one of his recent videos, Theo is complaining about RLS, how it is used in Supabase, and that it's not a good idea. But is his concern really valid? I have been working on backend systems and microservices architectures for more than a decade now, and for me, row-level security is actually one of the best technologies out there. So let's have a closer look. But let's have a look what he is really saying.
This concept became more popular again during the GraphQL era, where everybody was trying to replace their SQL database calls with a GraphQL layer in front of it. I think this is a bad pattern that set a terrible precedent for the direction of databases going forward.
And a little bit later in the video, he says,
You have to build authentication into your database. And the shape of that authentication usually comes in the form of row-level security, which means that you have a procedure or a query that determines whether or not a user can make a query or get access to a thing. And you define on a row who does and doesn't have access to that data. This results in your API code and logic being a lot harder to work with if it's even owned by you at all.
He has a very good point, because putting logic into your database, well, this has never been a good idea. And this is also true for row-level security. If you have a very complex way to access your application or your API, putting all of this into the database is not really cool. And even worse, and that's totally true, if you're not controlling the database. Let's take the Linux file system as an example. So here I have my Linux terminal, and I can just create a little directory and change into it. And within the directory, let's just push some hello world into a random text file. So if I now run ls-al, what I see here is that the file I've just created has read-write permissions for my own user, and it is owned by me, and it has just read permission for everybody else. And I can give read and write permissions for others as well. For example, if I want to have everyone to have the write permission, then I can just do this. And if I run this again, I get now read and write permission for everyone, which of course is not really what I want, but this example shows very well that you can actually protect data right where it is and handle permissions right as close to the data as possible. And if I run, for example, now the ls or the less command and read the context from the content from this file, what actually happens is that this application is executed with my user, and that's actually why it is allowed to read this file. While if another user would do the same command, well, in this particular case, they would be allowed to do that. But if I remove the read and the write permissions from that file for everybody else so that only I can read it, then this file is no longer readable, and also the less application would not show the content of this file if this is executed with a different user. The Linux operating system doesn't use row-level security under the hood. And row-level security is, of course, much more complicated because you can actually put every SQL query possible into the row-level security policies. So that's obviously not the same kind of thing, but you can use it in a very similar way. And a good example for that is multi-tenancy applications. So let's say your customers are using your service for serving their own customers. So in this case, what you want to do is actually you want to separate the data for each customer, well, basically in a separate database. But running a separate database for every customer is actually some effort to do and to build and to maintain, and you have to set this all up and to run it. And a much cheaper solution to do that is actually just to protect the data of each customer using row-level security. So when you, for example, have a table and you put for each customer a customer ID into it, then all data that belongs to the customer can be protected by row-level security, and there is no malicious access just because your application level authorization didn't actually do the right checks. But there is another point. Let's see what else Theo has to say.
Users and databases should not interact. There should be a layer between them, and we usually call that layer the API.
I absolutely agree with him on this. Of course, you should have an API in between the data and your users. And this API, of course, needs to do also the authorization of your application. But this doesn't mean that you shouldn't have additionally a permission set on top of your data, close to your data, which basically can be implemented by row-level security. And in my opinion, the right place to put this kind of permission is the ORM. So ORMs like Drizzle or Hibernate in the Java world, well, they actually could introduce a concept of permissions on top of data within their existing abstractions. And they could even use their own database migration tools to easily set this permission set up. And when I say permission set here, well, this could be an abstract permission concept similar to the Linux file system. But on the other hand, it could be implemented automatically using row-level security in the database. Personally, I got introduced to row-level security first by Supabase. And on their implementation, well, I think they actually made a pretty good implementation by using JOTs for actually checking the permissions in row-level security. And that's actually a pretty nice idea, as JOTs are just an industry standard. There are standard papers describing actually how a JOT should look like and how it's encoded and decoded and what properties go into it. So this is actually a pretty good way to have a verifiable piece of information within the database to check this. So how this could look like is that you have the application that is getting a request from the outside world, and then the application is passing on the JOT that it gets from the client to the database so that the database can do a permission check if the current user that uses the application is actually allowed to access this data and, well, read or write or whatever do with it. And if we have an industry standard or an industry concept on how we do permissions on data in ORMs, well, then row-level security becomes much less complex, as the concept itself is just a technical implementation detail, while the overall concept of permission checking close to the data could be very, very well standardized across different applications. Thanks for listening to me, and if you like it, please press the like button and, of course, subscribe to the channel. See you next time.